As was already stated, my name is Bethany Berard, and I'm a PhD candidate at Carleton University. And today I'm hoping to talk about sensing light, or how we can materialize digital photography through the sensors that make it possible. So first, I'd like to say thank you to UCR Arts and Dr. Gleason for organizing such a wonderful event and a really great selection of papers. For those of us that are interested in the technologies of photography, this kind of conversation is fantastic. So this presentation today comes from the beginning of a book project that looks at the technical and social history of CCD sensors and kind of the sensors that come after, and look at the origin of this invention to consider why digital imaging is a relatively late addition to digital culture and some of the consequences, be they technical, environmental, or cultural, of image sensors. So through a technical history, we can see that despite ubiquity and a general cultural sense of ephemerality, digital photography isn't really cheap or convenient or immaterial if we take a wide angle view of its impact. And so this project locates the charged couple device sensor and the beginning of digital photography in Bell Labs, where it was invented. So for those who might be unfamiliar, Bell Labs was founded in 1925 by AT&T and Western Electric, and it was, and still to this day, is an industrial research and scientific development company. Bell Labs has a number of notable inventions: the transistor, the laser, the Unix operating system in the programming language C++. The lab has been awarded 9 Nobel Prizes for scientific invention and is today owned by Nokia, with research labs around the globe. So this project situates the invention through a legacy of work on networks, information, and memory, rather than the more formalist ideas that have historically grounded much of the work on the history of photography. So the hope here is that we might provide an interesting addition to how we view digital photography as part of both the history of technical images, as well as suggesting the place of analog photography in the history of networks and information, not only when it becomes digital. So the study of photography has emphasized the context of a photograph, highlighting often photographers, photographs individually or as a collection, and generally has paid less attention to the techniques and technologies used on the whole. The limits and affordances of the camera don't often factor into critical case study analysis, which is interesting, as these affordances or constraints structured much of early photographic possibilities. There are, of course, many reasons for this, and at this conference and others, there are many people who are starting to highlight the role of technology in photographic history, and we can see this shift kind of taking place. So when one traces the history of photography through the hardware, or put another way, through technical shifts of cameras, we can see a few sets of questions emerge. 1, does anything hold between inventions? And 2, are there material components that bridge the analog-digital divide? These questions have kind of been at the center and the core of this project. So despite persistent attention to the indexical relation, cameras, regardless of their analog or digital nature, record the fall of light, not a world of objects, according to Sean Cubitt. He continues, quote, "The photon scale events that catch the light and hold it still are themselves invisible and have to be worked on to visualize them. The whole apparatus of lensing, photochemistry, grading, post-production, and printing is work on, in, and with light. Light, it seems, bridges the analog-digital divide." So if we stop for a second to focus on the photographic product or photographic artist, and we kind of reorient our attention around the camera, photography can be understood processually. And this follows Joanna Zielinska, who, quote, "treats photography as a set of processes rather than just objects." A processual beginning to discussing photography highlights a few things. First, it situates photography firmly in media studies as the process is the mediation of light. Second, it suggests the primacy of mechanics of how the images are made over what they are of or how they function. And third, it suggests an operational diagrammatic is possible. This is possible independent of an analog-digital divide, where the ontological status of photography is reconsidered in terms of how light is captured, how light is transformed, and how light is stored. The suggestion here is that in looking inside the camera and tracing how and where light moves, there is something of a diagrammatic that may emerge. What we might see are stable components of photography that challenge the position held that digital photographs rest on ontologically unstable grounds. By reorienting the history of digital photography around the CCD sensor, the elemental nature of the digital photograph is made visible as the silicon, metal, and the material conversion of light to electric pulses rematerializes the digital photograph. In doing so, this responds to Jacob Gabory's assertion that the majority of scholarship on computational media focuses on the visual output of computers, text, image, and interaction. And, quote, little account has been given to the material processes that produce digital images. Examining the CCD sensor and its material processes allows for possibilities to respond to this gap, where we are looking at kind of how these digital image hardware components work together, how they've changed, and what they produce. So methodologically, this draws on a particular legacy within media archaeology, where the focus is often objects themselves. And so instead of the story, narrative, or image, Wolfgang Ernst's media archaeology posits the diagram as the starting point for analysis of technical media culture. Diagrams are to be understood in the very technical sense of a visualization of information, patterns, circuits, and relations, which give an idea of how the otherwise so complex machines work. As we will see, the invention of the CCD itself is the product of a diagram. As co-inventor William Boyle wrote, the invention of the CCD took place in one afternoon over one of our frequent brainstorming sessions. We drew something on the blackboard. We began with a diagram, and before it was finished, we knew we had something special. Using what UC Parika has termed an operational diagrammatic, we can pull through the history of cameras how light is captured, transformed, and stored to show the step-by-step processes are not entirely so different as the analog-digital divide might have us suspect. In most cases, transformation and storage are in two parts. And so it is with the CCD sensor that the transformation is just a physical, not chemically induced transformation. So I'm going to go through kind of three analog examples, and then we'll look at the CCD itself to kind of compare some of these processes to show where we might see similarities. So wet plate Carleton processes, the term wet plate photography comes from the photographer covering the plate with light-sensitive emulsion. And the diagram here is particular to the daguerreotype. So in doing so, the photographer creates a photographic sensor that captures the image. The emulsion often contained silver halides, and they react when exposed to light, similar to the emulsion still found in film cameras today. The plate has to be developed at the time the image is captured. And there were three general types or ways that this happened. The first, the daguerreotype, where plates were polished silver or sometimes a silver coating on a copper plate. The ambrotype, which used a glass plate and thus needed fewer chemicals to develop, but prints couldn't be duplicated. And then the tin type, which was the cheapest and easiest of all wet plate methods, where the plate was a thin piece of metal with a layer of dark lacquer. So the second example is the Leica camera. And so these cameras are smaller in size, but more importantly, their lenses were more advanced, and therefore, under certain conditions, photographers could hold the cameras while taking photographs. But what is kind of important for this discussion is the way that roll film functions. And so what happens is when you can take multiple exposures, and of course, this isn't the first camera with roll film, but it's one of the first ones with a stable enough lens to kind of make candid photos possible. The rolls of paper that were coated in the same gelatin bromide solution allowed the Leica camera to be more than one photograph taken kind of in a day or in a moment in an event without having to reload the camera. And so the third is the Polaroid, which is a photograph that can be produced instantly. And so while the first camera prototype was developed in 1947, available for the public in 1948, this camera was considered to be a novelty for two reasons. It was much more expensive than the majority of Kodak's cameras, retailing for around $90. And more importantly, within 60 seconds, the photograph was produced in front of you. And so the diagram here is of the Polaroid SX70 lens camera, which comes later. But the paper negative and positive were both developed inside the camera. This is kind of Polaroid's contribution. And as such, it was dubbed one-step photography because there was just one step between exposure and final print. It's not only one-step photography, as it's also one-print photography, since one print was produced in the process and the negative could not be used to create a duplicate. And so while these cameras add something to the social life of photography and address a weakness of prior cameras, the Leica is more portable, more focused. Polaroid becomes a mobile darkroom. When we think about how light is captured, how light is transformed, or how light is stored, there's more similarity than different. In all three, light is focused through a small hole. It hits a particular light-sensitive material and is transformed. Something is added to fix or store the transformed light, and off we go. Open up any camera, you see that the light is focused. There's a light-sensitive material that captures the light. It has to be fixed. And regardless of the format, this is never instantaneous. We think that in digital photography, it's so different because the capture and fix are in two parts. But we can see that this is often the case. The display of the image once fixed might be the change in digital photography, but to capture the image, the process remains the same 3 steps. And so we come to the CCD sensor. Foundational to the development of digital imaging generally, charge-coupled device sensors convert light into electrons, read the accumulated charge, and convert this electrical charge into binary form that can then be read by a computer processor as a digital images. The CCD itself is a layer of silicon that's positively charged so that it's deficient in electrons and oxidized at the surface. An array of metal electrodes is added on top of the oxide to form gates, creating capacitors that can store charge. Voltage is then applied to the gate, which repels the silicon's positive charge, or positive carrier, and creates a potential well at the silicon surface. When a photon hits the silicon, it creates an electron-hole pair, and the electron moves forward toward an electrode into the well. Electrons accumulate in the interface between the silicon and the oxide, and when a sequence of high and low voltage is applied to adjacent gates, the electrons shift from one gate to the next until they reach the edge of the chip, where the level of charge can be read as a measure of light intensity. The CCD output is an analog signal voltage directly proportional to incident light intensity. Now, many of these terms may not register with analog photography, but a measure of light intensity seems to be common among all. So the CCD exploited a common characteristic of semiconductors generally, their ability to capture patterns formed by negatively charged electrons and store or read that pattern. The pattern would be created electronically on the surface of the device when used as memory, But when or if the material is light sensitive, the pattern could also be formed by focusing an image on the silicon surface. Stronger light creates a stronger electrical charge, less light, less charge. So if we return to consider how light is captured, how light is transformed, and how light is stored, one thing the CCD introduces to photography is that the transformation and storage of light are not singular. Oftentimes, this was the case. One CCD sensor and one memory card produce and store many images. As Sean Cubitt has pointed out, quote, to make the CCD ready for another exposure, the electrons are drained in the precise order of their layout, with a bit of delay as this charge is converted from charge to voltage and then amplified. So the digital term latency covers over a process analogous to the latency of wet photography, the delay prior to the camera cleaning itself up, ready for the next shot, the time taken to convert electric charge to voltage that must then be converted into digital form in order to move to storage. They both occupy the same position of invisibility, and though far swifter, contributes the same delay as fixing the chemical image. In both processes, there is a distinct moment when the photons have been converted into something else. Electrons, silver ions, fill in the blank. But that something else is not yet visible. The camera makes something new when we think of the possible materialities in how time and space can be composed and compressed visually, how events and likeness can be recorded and preserved, and what can be learned about the natural world, all of which remains possible regardless of how the camera might change because of the primacy of light in all photographic processes. So what does this diagrammatic offer? Looking through the camera emphasizes a different kind of processual definition of photography, located primarily in the processing of light, where the material capture, transformation, and storage highlight commonalities. Estimates place the value of the global image sensor market today at 17 billion. While 90% of image sensors today sold are complementary metal oxide semiconductors, or CMOS sensors, which is kind of the second step after the CCD. CCD sensors continue to play a key role whenever higher quality and greater light sensitivity are required. Sony's new image sensor is rumored to be an image sensor that will be used in the iPhone 5, which roughly doubles the saturation signal level in each pixel compared with these more conventional sensors. So in other words, the sensors can capture more light and reduce overexposure or underexposure in certain settings, enabling a smartphone camera to clearly photograph a person's face, even if the subject is standing against a strong backlight. So innovation in image sensors specifically has clearly not slowed. While we have only begun to explore the possible uses of sensors generally, it is clear that image sensors continue to be at center stage of this conversation. Famously invented in one afternoon, the CCD sensor in many ways revolutionized potential in terms of capacity for photographs to become even more ubiquitous than they already were. Polaroid inventor Edwin Land famously predicted in 1970 we would one day realize a camera, quote, that would be like the telephone, something that you use all day long. Whenever an occasion arises in which you want to make sure that you cannot trust your memory, or when you want to record any object of great interest to you or any beautiful scene. A camera which you would use not only on the occasion of parties or for trips or when your grandchildren came to see you, but a camera that you would use as often as your pencil or your eyeglasses. The ease, speed, and issues with which digital photographs are taken, circulated, and edited, shared has kind of dominated this discussion. So what can we learn about digital photography through a history of the sensors that turn light into electrons? How can an analysis of the elements that constitute digital images offer insight into contestations over their ontological or material status? The technical story of the CCD suggests that digital photography has more in common with analog modes than we might think. So while the history of photography gives us one perspective, it can contribute multiple kind of examples or diagrammatics that might be able to give us a different perspective on the role of the CCD sensor today. Thank you.